Alright, in this video we are going to talk about domain and range and how to find that for graphs that don't just have random points plotted like we did in the last lesson. So first I want to say that the examples I'm going to use are on the page where this video is, so if you didn't get those or download those or look at those, just make sure you do. My intention is that you do this with me with this video, but if you can't print it off, just make sure you're watching the video. Also make sure you are paying attention because there may be questions that pop up. Right? So one of the PDFs is a foldable, and it's going to look like this. Sorry, let me move this a little bit. It's going to look like this, and then on the, if you are able to print it off and cut it out, it'll have the words domain on the sides, and it'll have the words range on the up and down pieces that you can fold. The goal of this is to be able to use it at first and then maybe not need it in the future. If you do happen to be able to print this off or can do something with this, you can cut this out, put it on like a piece of paper, cut out the examples, and do one side of the examples with grid lines and the other side of examples without grid lines. And again, if you can't, that's okay as well. Alright, so let's get into this. Because when we're doing the domain and range, remember your domain is all of your x values and your range is all of your y values. So when we're looking at these functions that have actual graphs and are not just random points, we're still looking at all of our x values for all of our domain, for our domain, and all of our y values for our range. But the way we write out our domain and our range is going to be different than how we wrote it out when random points were just plotted. So I have my example in my foldable. I'm air quoting right now. And what I want to do is kind of take my left and right flaps and put them to the edges of this. So I can see the furthest left and the furthest right points. So these are acting as like barriers, so I can't see past those. Now, if that's too much at once, what you can do is take one and put it at the y-axis and count to the left, and then take the other, put it at the y-axis, and count to the right. If it's not too much, then you can just put it at the left and right points and count from there. So we want to see what is the furthest point to the left and what is the furthest point to the right. So how far does it go to the left and how far does it go to the right? So these are a little small. I'm going to look and see. Looks like -4. So I have, domain and range written down here. Sorry. It goes left -4 and right +4. That's not always the case. Sometimes the numbers will be different, but in this case they both happen to be 4, just one is negative. So when we write this domain, we're going to start off with that curly bracket. Remember, that's the set of. And then we're dealing with domain, so we need to kind of tell this or say that this is for x's. Now, this is weird, but we just need like a straight line right next to it. It's just to kind of say, all right, this is the beginning of how we're writing the domain, and then everything else is going to be the actual piece of the domain. We said the furthest point to the left was -4. I'm going to go ahead and type -4. And then it goes from -4 to +4. That's all of your integers, but it's also all of your rational numbers, like your fractions, your decimals, included in that. So like 0.5, 0.75, like all of those decimals in between 0 and 1, and 1 and 2, and 0 and -1, just all of those numbers are included. So we can't just say just the integers, just 0, just 1, just 2, just -1. We have to say all of them. So I'm going to say it's from -4 to +4, and the way we do that is to say, or we use these symbols, the less than and greater than or equal to symbols. So here I'm going to say it starts at -4 and goes to +4, so I'm going to say -4 is less than or equal to, sorry, wrong thing. X, which is less than or equal to 4. Now what that means is the value of X, or the domain of X, is everything from -4 to +4. The decimals, the whole numbers, the integers, everything in between that. So the set of -4 to +4 with everything in between. So this is the format that we're going to be writing these in. If it has a starting point and an end point, this is what it'll look like, and that will make sense a little bit more when we talk about the differences between these graphs. But I can say our domain for this graph is -4 to +4. Okay, now I want to look at the range. Remember, your range is all of your x values. So I want to see the lowest to the highest. So domain is furthest left to furthest right. Range is furthest lowest to furthest highest. You're still kind of thinking least to greatest, just it's a little different. Right? So for our range, you could put y. I'm going to put f of x, since that is also y, and we'll talk about that here in a bit. So you may see it like this, or you may see it like, now these numbers are not correct, so I do have to change those. I'm just trying to show you the format. So f of x, or you may see it as y. Whichever one you are more comfortable with writing, for now, that's fine. Now, let's go back and look and see what is the lowest point of this graph. And it looks like it's at -1. The lowest point of this graph is at -1. And the highest point, so here is my x-axis, and if I count up, it looks like it's 8. I think this is a 8 by 8 graph. So our lowest value is -1, and our highest value is 8. So the problems we do on this example page will be set up very similarly with the less than or equal to symbols and the x or y in the middle and the x or y in front. So this range is saying it starts at -1 and it goes all the way up to 8, including all of the whole numbers, integers, rational numbers in between. Okay, so now I'm going to go ahead, I'm going to move my example problem back. And I'm going to move on to number 1. Okay. Now, there is a slight issue with this number 1 because it's supposed to be a straight line, and you can't really see that here, so I'm going to draw one in. I'm not sure if that's going to be thick enough. Oh yeah, that's fine. Alright, so there's supposed to be a line right there, it just was not showing. Alright, so now that we have that line, now we can look at our domain. Again, we're looking at the furthest left to the furthest right. So in this example, I'm going to do it where I separate it. So I'm going to put this at x-axis and see my furthest left point is at -7. And then I'm going to switch it. Put this at my my y-axis. And put this at my furthest right point and count how many that is. And I see that that is also 7. So remember, I said that that may not always be true. It just happens to be true here. So I can say that my domain starts at -7 and goes to +7. Oh, I forgot I still have that. Okay, so anytime we do the domain, x needs to be in the front and in the middle. And then for range, either f of x or y. And I didn't say this, but this notation is called set builder notation. Later in your math career, you'll learn other notation that's similar. It means the same thing, but it looks a little different. So for this, our domain is -4 to 4. Now let's look at our range. Here, there's really only one value that the range is at. It doesn't go further than this point or lower than that point, and it doesn't go higher than that same point. So when you have something like that, you're going to say that x or y, whatever it is, depending on if it's a vertical or a horizontal line, because we're talking about our range, I can say my y value stays the same all the way across, and that's going to be at 3. So when we have something like this, it'll look more like y line, y equals that value. I know these words are in the way. Give me 1 second. So there's not really like a starting and ending point because it's always the same value. So here it's going to be y equals 3. If I'm going too fast, pause the video whenever you need to, and then after this video, if you feel like you need help or this did not make sense, please message me and we can work through some examples together. All right, moving on to example number 2. Now, I'm doing domain first and then range, but if you want to do range first and then domain, that would be completely fine. Here, do we have two different starting and ending points for our domain? That should have been yes. My starting point for our domain is over here. Ending is over here. That question is going to come in handy when you start to see the other examples that we're going to do here shortly. Right? If the grid is too small, go ahead and move this to the x-axis so you can count from the x-axis to the left. And that should be -6. And then from the x-axis to the right. And that should also be 6. Not also be, it should be 6, sorry. So curly brackets, x line. I just need to copy this a little bit. There we go. Our lowest point to the left is -6, and our highest point to the right is 6. Remember to put your curly brackets at the end. Okay, so this domain goes from -6 to 6. Now let's look at the range. And just like I split up the domain just then, I can do the same thing with my range. So if I wanted to just look at the lowest point value and not worry about the highest just quite yet, I can go ahead and put this on my x-axis and count down. So that should be at -3. Starts at -3. And then I could do the same thing, move this to my highest point, put this on my x-axis so I can see what my highest point is. And that is 3. So curly brackets, y or f of x, line, and this one, because it has a starting and an ending point, not like the example 1, or the number 1 that we just did, this one is actually going to be -3. I have to change this to y, and change this color to 3. Moving on to the next. Oops, that's not what I meant to grab. Now we're going to do number 3. For number 3, I can see that I have 2 different starting and ending points for my domain. So I can find the lowest point to the left, or the furthest left, and the lowest point to the right, or the furthest right. And again, if counting that space is too much, you can fold it over some more to the y-axis, so it's a little less confusing. This is example 3. Yes, I just want to make sure. Alright, so 1, 2, 3, 4, 5, 6, 7, -7. And then to the right, it looks like this is going to be 7 as well. that is 7. Right. So what does this start off with? Curly brackets, then x, then the line. Then our lowest point to the left was -7. And our highest point to the right was 7. And end with a curly bracket. For our range, if you're starting to get the hang of this and want to go ahead and take off and do the rest of these examples on your own, you are more than welcome to. What is the lowest point of this without me putting this foldable up here? See if you can figure that part out. You should have found that your lowest point was -5. Even though there are 2 points right here, they both stop at -5. So your lowest point should be -5. And your highest, if you went ahead and found that, should be at 4. So curly bracket, y now, because this is range, -5, make sure y is in the middle, so less than or equal to y, less than or equal to 4. And I can put that example back. I will say that on the first page of examples, I'm not going to do every single one because I do want you to be able to try some of these on your own. So we're going to do 4 and 5, and then I'm going to leave 6, 7, 8, and 9 for you to do from those examples. But I will have the answers posted so that you can check yourself, or we can go over them. Moving on to number 4. Okay. Can you find the domain and range of this on your own? If you can, go ahead and try that, and then you can pause the video and unpause it and see if we got the same thing. If not, keep following along. For our domain, the furthest point to the left is -6, and to the right, +6. So I could go ahead and do the range, but I want to make sure I write this down before I do that. So because this one was the same, I'm just going to copy this so I don't have to retype it. Right. And then looking at our furthest lowest point, there we go. My computer decided to stop working for a second. Lowest point is -3. And then our highest point, it seems to be at 2. I'm going to copy this and change it a little bit. Curly bracket, y, line. Lowest point is at -3, but the highest is actually at 2. And then last but not least on this page is example 5. Okay, and I'm going to do this out of order. I'm going to do the range first, just because, like, you could have still done the domain first, and that's fine. So our lowest point, it looks like -7, and then our highest point, is at 7. Yes. The grid lines are really small, so I'm having to double check myself. Okay, so again, I'm going to copy paste, but I'm just going to change my numbers. So my lowest value was -7, and my highest value was +7. And then for the domain, our lowest point to the left is -4. And then our highest point to the right, oops, wrong thing, is +4. So because this was the same, I'm just going to go ahead and copy this. But curly brackets, curly brackets, x line, -4 is less than or equal to x, which is less than or equal to 4. Trying to get these words out the way. Trying to put the graph back. Right, so like I said, try 6, 7, 8, and 9 on your own. You can do that now, or you can wait until the end and try them all at once. Right, and now we're going to move on to the backside or the second page of examples. And I want to ask you a couple things. When you look at these graphs compared to the other graphs, what's different? What do you notice? Hopefully you're noticing that there are no grid lines, so maybe you're wondering and thinking, well, how are we going to count? And hopefully you also notice that in the other examples, those had endpoints or points at the end of the graphs, and these graphs have arrows. So what that means is the setup is going to be slightly different because the arrows mean something different. Okay, so let's go ahead and start off with this first example, or with the example from this page. And before we talk about the domain and range, I do want to go ahead and talk about these arrows. So these arrows mean this is going to go forever and ever in this direction to the right, off my computer screen, off the page, forever, to infinity and beyond. Yes, Toy Story. And this is going to do the same thing, go off my computer screen to infinity and beyond, to negative infinity and beyond, in that direction. So it's going to keep going off the page. What that means is every single number possible for your x's is a part of your domain. We call that all real numbers. And when we write all real numbers, it's going to look a little weird, but I can't contain it. It doesn't have starting and ending points. So anytime it doesn't have a starting and ending point, you may need to format it a little differently. Now, this is only all real numbers if you have arrows going in both directions. That means I have an arrow going all the way to the left and an arrow going all the way to the right. So my domain is all real numbers. My range, not so much, but let's do the domain first. So I didn't bother bringing the domain bars over because it's going to keep going. I can't contain it. Right, I had to find this symbol, but so it's going to start off the same way, curly bracket, x, line, and then we want it to say x is all real numbers, or x is an element of all the real numbers. What I mean by that is these symbols. No, they're a little too big. Alright, so it's this weird looking E. It's kind of like an elongated E, almost like a capital E, but it's rounded. That's just means element of, or like X is a part of. And then this is like a double R. So draw a capital R and draw a line. Hold on, like this. That was a terrible R. Just draw like a line from it. And that's going to be your real numbers symbol. So anytime we have something is all real numbers, we're going to write it like that. X-E-R. And that means it goes from negative infinity to positive infinity and beyond. Alright, now let's look at the range. Because here it looks like we have a lowest point because it starts somewhere. And if it's starting at the x-axis, what is the value of y? Should be 0. And then because of these arrows, it's going to keep going up and up and up forever. We don't know to what number, so we can say it starts at 0, but it goes up to infinity. So it doesn't have arrows in both directions, so we can't say it's all real numbers because it has that starting point at 0. But I can say it's every number 0 and above because it keeps going higher. So when we write that, it's going to be your curly bracket, y line, and then I can say that y is greater than or equal to, once I find that symbol, the starting point, which is 0. So it's going to look very different than the examples we were just doing that had starting and ending points. So all real numbers, you're using the ER, no matter if that's domain or range. And then if it has a starting point but goes on forever in one direction, you're going to probably use your greater than or equal to or less than or equal to symbol. So that was example 1. Or I'm sorry, that was the example. We're going to move on to number 1. We're going to do a little bit more of these ones together, but I am going to leave you a few to do on your own. And then, of course, after a few, if you feel like you got it, you can pause the video and keep going on your own. So, doing example 1. I'm sorry, doing number 1. I have to stop saying that because 1 is actually the example and 1 is number 1. Okay? For me, I see arrows going up and down. So for me, that tells me my range is going to be all real numbers. It keeps going down forever and ever off my computer screen to infinity, to negative infinity and beyond, because these are negative values down here. And then it keeps going up and up and up towards infinity off my computer screen. So it can't be contained. The range cannot be contained. So the range is all real numbers. Now let's look at the domain. If this keeps going down, and it looks like it's going down and slightly to the left, and this one keeps going up and slightly to the right, that means over time this is going to keep going up and more slightly to the right, and this is going to keep going down and more slightly to the left. So that means, in this case, our domain can also not be contained. It's going to keep going forever and ever in both directions, to negative infinity to positive infinity. So again, this one is also all real numbers. So X line, I need to copy this because I can't type those symbols. And Y line, Y. So in this case, they were both all real numbers. The spacing is a little off, so if that bothers you, you're writing, so you could fix it. I'm copying and pasting, so it's a little difficult for me. All right, now let's move on to number 2. Okay, let's look at our domain first. Now, when I put my foldable, when I try and move it over, it looks like I kind of have the same thing I had in example 1. This keeps going down and slightly to the left, and this keeps going down and slightly to the right. Now, you may be wondering, how do you know that? In this instance, I kind of just want you to trust me. I know that these graphs, the way they look, and when we go to graph these, it'll make more sense. But right now, I just kind of need you to trust me. That it will keep going down and to the right, slightly to the right, and this will keep going down and slightly to the left. So our domain is what? Should have said all real numbers, hopefully. But let's look at our range. Now for our lowest point, do we have a lowest point? Hopefully you said no, because these arrows mean it's going to keep going down forever and ever to negative infinity. So we don't know the lowest point. But what about the highest point? I'm trying to not cover this on purpose. This is the highest point, and it says this is at the point 0, 1. So what is the highest point? Hopefully you said 1 because the y value is 1 of this point. So it starts at 1, but it goes down. It's everything below 1. So in this case, it's going to be kind of similar to the example problem, except instead of it being greater than or equal to, it's going to be less than or equal to. Hopefully that's what you said. Right, so we found domain is all real numbers. That spacing's a little better. I have a little bit of OCD. You may have been able to tell in these videos. Right, so y is now less than or equal to, oops, I forgot my line. Y is less than or equal to positive 1. And let's put that graph back. So in these examples, we don't have grid lines, but some of the notes you'll see later, they will have grid lines and arrows. So if you get some example that looks similar to this, but now there are grid lines, you just have to find what that highest or what that lowest point is and count. Count the grid lines. Right? Now let's do this number 3. Now this should look somewhat similar to the example we did with the grid lines that had just the line. I'm going to go back to that for 1 second. Because in this case, our range did not move. It did not change. It was just y equals 3. That will also be the same case here, just maybe it won't be 3. Okay? Now, our domain. Can you look at this without me moving the foldables and tell me what the domain is? Hopefully you said it was all real numbers because this goes left and it goes right with the arrows. That means it's going to keep going forever and ever in both directions, left and right, or to negative infinity to positive infinity. So our domain, again, is all real numbers. With some of the examples you have that have arrows, a lot of the answers will just be all real numbers, and that's okay. Right? What about our range? It doesn't move past this point. It doesn't go lower, it doesn't go higher, so it stays there. So what does y equal? Hopefully you said 1 because they gave us the point 0, 1, where y is 1 in that ordered pair. I guess I could have brought the graph down. That's okay. Okay, and then our range, so our domain is all real numbers, our range is y1, y equals 1. And that's it. The computer is not like me today, it's just so slow. Right, moving on to number 4. Without me even putting this in the foldable, could you tell me what the domain and range are? If you were able to look at this and say, well, it has an arrow and it keeps going left, it keeps going right, so the domain should be all real numbers, yes. This keeps going left and down, and this keeps going up and right. So the range should also be all real numbers, and that would also be correct. So if you were able to determine that, you are getting better at this, and you might be able to go ahead and do number 5 on your own. 8 and 9 I do want to do with you, just because those are a little bit different than some of the ones you've seen. Oh, I forgot, because I'm skipping some of them. 6 and 7, you should be able to go ahead and do. They're not on here, so you can go ahead and do those. I'm going to stop bringing them up to the foldable to see if we could just do it off of the picture. So 5 has a domain of all real numbers because it's going to keep going down and to the left, down and to the right. What do you think the range is? So I'll give you a second to ponder that. I will say it's very similar to number 2, it's very similar to to the example problem. If you've already figured it out, here's your chance to see if you got this correct. This should be y is less than or equal to 0, because it has a starting point at the x-axis, so it's everything from 0 and below. Right? Now let's talk about 8 and 9. For the domain of 8, it's weird because there's 2 parts to it. And we won't be graphing anything like this. You may see this in another math class. This is just to kind of give you a more advanced domain and range scenario. So for this one, sorry, I was looking for something in my notes. I can see that this does go all the way to the left for my domain, and I see this one goes all the way to the right, but then it doesn't go to the y-axis. It goes all the way to the left to infinity, and then I can see it's this value and this value and this value and this value, but as it starts to get closer to the y-axis, it's not going to really touch it. And same thing here. This one's going to keep going to the right, And as it goes back to the left, it's going to touch all of these x values, but it's not going to touch the y-axis. So that means our domain is everything except the value 0. So in that case, we can write it as what it doesn't equal. We can also say it's all real numbers except at that value. So I'm going to type both. So if we want to just say it's everywhere except at the y-axis, or where x equals 0. Oops. I'm typing random things now. Okay. It would be x does not equal, so I'm going to find the equal sign with a slash through it. There we go. That means does not equal 0. Oh, except I didn't type 0. Okay. Or I can say, oops, that's not what I meant to put. X with these lines. Sorry, I'm looking at my own example that I have to see how exactly I wrote it. X, all real numbers. And then I'm going to do another line to kind of separate it, and also say x does not equal 0. So you could just say x does not equal 0, or you can say x is all real numbers, but x does not equal 0. Or x is all real numbers and x does not equal 0. Very similar. Now, for our range, it looks like we're going to, it doesn't go below. It looks like kind of the same thing that happened with that y-axis. It's going to keep going down towards the x-axis, sorry, but it doesn't really look like it's going to touch it or approach it. But it is going to keep going up forever towards infinity. So I can say that one is y is greater than, or y is just greater than 0. It's just greater than because it's never going to actually touch the value 0, so it's not included there. Right? And then for 9, as I'm looking at 9, let me extend this so it's not in the way. It looks like my domain keeps going to the left, but when it starts to come back to the right, it doesn't touch the y-axis. And then it keeps going to the right, and as it comes to the left, it doesn't touch the y-axis. So it's going to be the same thing we have here, where x does not equal 0. So I'm just going to copy this entire thing. So x is all real numbers except for at 0, or x is all real numbers and it doesn't equal 0, or just x does not equal 0. And then for the range, this looks like it's going to keep going down towards negative infinity. But as it starts to come up, it doesn't touch the x-axis. And then for this one, it keeps going up towards positive infinity, and as it comes down, it doesn't touch the x-axis. So it's kind of the same thing. Y doesn't equal 0 either. So this is going to be purple for a second and have x's in it until I change it. So it's going to be set up very similarly. I can say y does not equal 0, or that y is all real numbers but doesn't equal 0. Sorry, I just had to fix a spacing issue. Let me copy this and change this color. So like I said, you won't get examples like this, like 8 and 9. They were just more advanced ones for you to kind of test and try out. So you've now seen most of the examples from these example pages. Again, I want you to do 6, 7, 8, and 9 from the grid lines example page, and then 6 and 7 from the arrows page or the non-grid line page. And you can check your work on the notes page. Right? And I just want to talk about a little bit more of the notes, and we're going to go into the actual domain and range notes for the last bit of this video. Right? So this is on the second part of day 2. Day 2B, I think that's what this one is called. And we're just going to go through a couple of these examples and some of this vocab. So when we were just doing those examples, we found the domain and range on 2 different types of graphs. I refer to them as the ones with grid lines and the one with arrows. Now, both of those were similar types of graphs. They were in the same group that we're about to define. So when we talk about these 2 different types of groups, we're talking about the ones we were doing in the relation lesson, the ones that were plotted randomly. So those, a graph that consists of points that are not connected, that's what those were. That was a discrete graph, which means they're not connected. And the grid line examples and the arrow examples, those were all continuous graphs. Continuous, I can never spell this word. Which means a function graph with a line or smooth curve. You know it's a continuous function if you can, let me pull up one really fast. If you can put your pencil or your finger or a marker or whatever it is you're writing with at one point and not pick up your pencil or pen or finger or whatever until you get to the end. That is continuous. So like in this one, I have to pick up my pencil. Now you can't really see it with my arrow, it just looks like I'm drawing, but I'd have to pick up my pencil to plot each of these points. So this is a discrete graph, this is a continuous graph, but the ones with arrows are also continuous graphs because I can start at one point and not pick up my pencil to draw the next point. Right? We're going to do the example on this page. Maybe if it lets me. There we go. I'm going to ignore this part because this really shouldn't be here. The answer is in the answer key, but we're really going to talk about this more in the last lesson. Right? So in these, they ask us to find the domain and range. They're also asking us in this example to find if it's a function. So that kind of ties back into our last lesson, determining if a relation is a function. So we're kind of doing 2 things at once. Right? So for our discrete graphs, we are going to list out our domain, list out our range, just like we were doing in the last lesson. I'm sorry, I keep saying last, but I mean the first lesson. And what I'm going to do is look left to right to see my lowest to highest points. So my lowest domain point to the left is -4. Next is -2. Next is -1. Next is 1. And then last is 3. Remember that these need to have the curly brackets to mean the set of these numbers. For our range, I'm going to look at the lowest value and work my way up the graph. So my lowest value is at -4. And then moving up, I get to 2. Get to the value 2. This one's at 3. And my last one is at 4. Okay? Remember that you can determine if something is a function by using the vertical line test. So I'm going to go ahead and do that. And you can probably see, I just want to draw the lines to be very accurate, or as accurate as I possibly can. Okay, so if I draw a line right here, that's not touching any other points. This one's not touching any other points. Same here, same here, same here. So I can say that without a shadow of doubt, this passes the vertical line test, so this is indeed a function. Okay. Now, I'm not going to go through each of these examples. The answer key is posted. I do want you to try a lot of the ones that I don't do, and I'm only doing 4 of these examples. So try the ones that I'm not doing. Message me if you have any questions. So I'm going to go to this example 2 now in the notes. Now notice that this says x-intercepts zeros and y-intercepts, and it says we'll come back to this for lesson 4. We are not going to discuss that in this video, but in the Unit 4 lesson, I'm sorry, Unit 4. Unit 2, that's the unit we're in, but lesson 4, it will cover those answers. There won't be a video on those, but it will have those answers. Right? So now for this one, this is a continuous function. So with our continuous functions, I need to look at the furthest point to the left and the furthest point to the right. So I'm going to do that by kind of drawing in some lines. And I want them to be different than the lines we use for the vertical line test. So I'm going to make these like dotted lines. Right? So my furthest point to the left is going to be at -5, and my furthest point to the right is going to be at 6. So even though this is in the notes and we're not using the foldable, I can still kind of make those barriers to see my furthest left and right points. Oops. So if it has starting and stopping points, making the barriers will help you. So our domain, because this is a continuous function, that's where I need x line. And this has a starting and end point, so it's going to start at -5 and end at 6. So that's going to be -5, there we go, is less than or equal to x, which is less than or equal to 6. Okay, and then I'm going to go ahead and do the same thing. I'm going to change the color of my barrier just so I can see it clearly, domain versus range. My lowest point is going to be at -3, and my highest point, it looks like this is the highest, but it keeps going up a little higher, so this is actually my highest point at 4. So -3 to 4. What I'm going to do is copy this and then change the variables and color. And numbers. So lowest value is -3, highest value is 4. Again, go back to the notes in lesson 4 to get those answers. But now I can look and do my vertical line test to see if this is a function or not. And I'm going to keep green. Okay. So I'm just going to start putting in these vertical lines at every kind of grid line to see, does this pass the vertical line test or not. So far it looks good, and really that's the only time we were really concerned, because everywhere else it's only going to go through this line once. Oops, that one was crooked. That one was also crooked. But you get the idea. So I can say that this is a function. Okay. I'm going to skip this next one, let you try that. I'm also going to skip this one and let you try that, and I'm going to move on to example 3. Yeah, I'll do example 3. I was going to do example 4, but I'll let you do that. So example 3, this is a continuous function, so it's going to have that weird domain and range. Oh, it's not letting me paste it. Okay, so I'll have to just retype it. That's fine. Right. Now here I see that this is going to keep going down, but it's also, so this is where I said, trust me, but as I'm looking at this, I can see that it does go slightly down and to the left. So, I'm sorry, I blinked out for a second. And this one goes slightly down and slightly to the, or it does go down and slightly to the right. So I can say that this is all real numbers. Right, that took me a second to get the symbols. But remember it's the E and the R because it is all real numbers. And then for our range, it looks like we don't have a lowest value because it keeps going down towards -infinity, but up, as we go up, I can see that it does have a highest value. So I'm just trying to make a border. And its highest value is at 3. So it's everything below this value, so I can say it's y is less than or equal to 3. So this is one of the examples I said that it may look a little different from the examples we were doing earlier with the arrows that didn't have grid lines, and now it has grid lines, but we can easily find where it stops and starts. Also, I said something about this would be like the continuation video, but I realized that I've just been continuing this video, so it's just going to be one video, so ignore that earlier comment. Okay, I'm going to go ahead and do the vertical line test so that we can see if this is a function or not. Okay. And I'm just going to kind of, again, do this at every one of the grid lines, hopefully straight this time. So it looks like it is not crossing the line more than once. That was a very crooked line. My apologies. So this is a function. Okay. I'm gonna skip around a bit. Again, there are a lot of examples in here that are very similar to the ones we did with the foldable. There are some that are slightly different, and I want you to go ahead and try those. And then there's practice work, which is just more examples. I want to do this example. And there's one other example we're going to do, and that's going to be, I'm sorry, 2 other examples we're going to do, and that's going to be all. Right? So for this domain, bells should be going off, light bulbs should be going off, because this has arrows going left and right, which means our domain is going to be all row numbers. I did mean to copy this and forgot, so let me go back and copy that. So curly brackets, x line, x is, of course it won't let me paste ever. Let's see if I can paste from up here. There we go. Our range, however, is different. So let's look at this. Because here I see that this keeps going along this y value, and this keeps going along this y value. Doesn't go up, doesn't go down, it's a horizontal line straight at that y value. Kind of like the examples we were seeing like this. So that means it has a starting and stopping point. Even though the function itself has arrows, the arrows really only apply to the left and right. It means it keeps going left and right, not that it keeps going up and down. The the range starts at -6 and goes to -2, and that's it. So the domain is going to be a little different than the range is going to be a little different than the domain. Because we have that start and stop, here we're going to need the format where you have those endpoints, So it starts at -6, where the lowest point is -6, and then it goes to -2. So -6 is less than or equal to y, which is less than or equal to -2. So even though you have this function that has arrows, it can still, one can be all real numbers, the domain or the range, and then the other be more restricted and have these endpoints. Now when we look at the vertical line test, hopefully you should be able to see by now that this will not be a function because of all of these values right here. All of these touch the graph, or touch the line at more than one place. That was not a straight line. So all of these areas make this not a function. Right? On to the next page, we're going to do this example. I do want to say that this is going to be very similar to the one we just did. It's just going to look a little different. Or the function itself looks a little different. So our domain, if I'm following this, it has arrows. That means it keeps going to the left. If I follow it this way, it keeps going to the right. Even though it has this arrow down, it looks like it's just repeating this function. And in a later class, you'll find out what that function actually is. We're not going to talk about that much now. But because it keeps going left and right forever and ever, this again is all real numbers. It goes from -infinity to infinity. Oops, I did not mean to do that. Right? And let's look at this range. Because this keeps going up and down, but it doesn't look like it's going farther than this point or this point, this is going to have starting and end points, just like the last one. Because it's not going to go past this line or this line. Oops, that was crooked. Because that looks like it's going to go past. There we go. That's better. So then I can say that this is going to have those endpoints and it's going to look a little different. Oops. So our lowest point here is -4 and our highest point here is +4. So this is -4 is less than or equal to y, which is less than or equal to 4. Now if we do the vertical line test here, this should be a function because it doesn't look like it repeats any x values, or any x values have more than one output. That was crooked. It's supposed to be straight, but that's okay. So as we start doing this, I see that none of this is repeating, even though my lines are very, very crooked. It's the OCD in me is like, fix it, but it's okay. I'm not going to do the entire thing because it looks like this just keeps repeating, but none of these touch more than one point or point on the line, so I can say, yes, this is a function. Okay. I know this has been a long video. We're just going to do one more example and be done. Right? I'm going to give you, I'm sorry, I was thinking of something else. I was thinking way ahead. Never mind. I was going to say I'm going to give you a hint on the x-intercepts and y-intercepts, but that's not in this lesson, so way ahead of myself. We're going to do this last example. Now, this is very similar to the other lines that were horizontal, where we had y equals some number. So what do you think is going to happen in this video? Hopefully you're thinking, well, if the domain is not changing, it's just one value, x is going to be, it's going to be x equals, right? So let's go ahead and do that. Because, again, the domain is not changing, it's only at this value 2, our domain is going to be x line, x equals the value 2. And that's it, because it doesn't change. Now what about our range? What would our range be? Hopefully you said all real numbers, because this does go up and down forever and ever in both directions. So because it goes to negative and positive infinity, it's going to be all real numbers. That's me like typing on my keyboard, so my apologies. Let's see if I still have this pasted. Nope, I forgot I copied something else. That's okay, I just gotta go back and find it. Right? Now, I want you to look at this very closely. Is this a function? Does this pass the vertical line test? I'm hoping you said no, because 1, it is a vertical line. Can't pass the vertical line test if itself is a vertical line, because it is touching more than one point all along this line. This one input has multiple outputs, so this is not a function. Wow, that was so cool, right? I know this has been a long video, sorry about that, but make sure that you go through these other examples, you come to me with any questions you have, and that you are checking the answer key.